Cool. 53 maximum subarray. Given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and returns its sum. Okay. I think this is, oh, we figured the O(n) solution, try coding our solution using the divide and conquer approach, which is more subtle. Uh, yeah, I mean, I think there's something called Cadane's algorithm. Well, let me see. What do I like? I mean, this is a true opposite, but something called Cadane's algorithm, and I think that just and technically is a dynamic programming problem in a sense that is based on previous states, but the way that I remember it, which means I've seen this before, something similar anyway. You just kind of you only need the last um, you only need the dynamic programming solution or the subproblem for your last array index or your prefix or suffix. How do you want to? So yeah, so I'm just gonna code it up. Mm, uh, that's but yeah, I think yeah, just Google this, and I think they'll kind of explain it more in depth. Um, Trouble with it. Mm, I think it's something like this. Watch, I may be wrong. So, uh, just someone literally just like that. I guess it's good to kind of get my fingers warm though. I didn't know other examples. Hmm. Yeah, I guess I'll try. At least one number. Okay. Mm, actually, might have to return the. That might be wrong for that one. So I need to. So that's a good thing that I test these things. Uh, yeah. Okay. Hmm. We have to handle some edge cases, but I think in general this should be okay. Uh, yeah. I think the way I heard it is that you could also choose no numbers, which you know, um, yeah, something like that. And the best is actually like some ridiculous things. Big number then, a million to a billion. Okay. I think maybe now I'm ready to submit. Let's do another one. Numbers. That should give me just 5, I think. I might have an off by 1. Okay. Uh, yeah. Oh no. Oh. Okay. That's a little annoying. I mean, that's. I guess that's enough Python. I mean, that's just because I didn't choose my cell value big enough. I don't know why they. Yeah. Okay. Is there infinite precision in Python? Right? Or did I make that up? What about goes 10 billion? I mean, that's. I would say if I was an interviewer, clearly would have defined kind of parameters like, hey, is this a big enough value before, running it or whatever. But it should be. I mean, okay, yeah, yeah. I mean, this is just literally a for loop, so I mean, I don't think you could get similar than that. And I actually did really well in running time, and I wonder what people are doing longer if I'm just doing 2 if statements. But I think there's a second part about divide and conquer, which is more subtle. Um, yeah, I guess. So I think the divide and conquer is, you have islands of these positive numbers, and then you want to connect them. The cost of connecting them is uh, uh, the sum of the negative numbers in between, and then it's just kind of like then you could divide kind of like uh, yeah, then you could recursively figure out how they want to do the divide and conquer. Maybe there's a greedy-ish we could do it that way, but like whether it's worth merging them for each kind of division, if you will. Yeah, I think I'm okay with this one though, and I think it's easy. I'm not going as usual. Don't usually generally go into it that much. I think this is actually not a I don't know. It's not an easy problem to do if you didn't already know the answer. I think necessarily, and a lot of people have seen it in some form. And it's kind of greedy-ish, but not. I don't know. So I think what I would say is, what would I say? Yeah, I mean, and yeah, I don't know. I don't think it's a good interview problem for me, but I feel like I said that a lot. But it is something that people do ask because it's simple enough. So maybe on a phone screen you could see it, but that's kind of my extent of how I feel about this problem.